Hello, friends. Today I'm going to start one lecture series on advanced manufacturing process, and this will be probably the first lecture video on this channel. We call it Nirvigyan. First lecture, I am going to talk about introduction of advanced machining process. So I will give you a brief overview of the most widely used advanced machining process, which are widely used in industry. Right. This will be the outline for I will give you a little bit introduction about the advanced measuring process, then classifications and based on the energy source, based on material removal mechanism, based on material types, process environment, scale of operation, and overall summary. I will talk about these things. What is machining? So anything if you are creating or shaping materials by removing materials that will be fall into the machining process, and this is why generally used for the metals, plastics, ceramics, composites, and any other relevant materials. So there are two broad categories of machining process. We first is traditional machining, or we call it conventional machining process. Second one is advanced machining process, and sometimes we call it non-traditional or non-conventional machining process. Right. So the objective of this lecture video will be like a compare principles of some of the advanced machining process, and what are the little bit over description of those techniques and applications. Traditional machining, so material removal mostly using the cutting tools. So in every process and for under the category of traditional machining, they have specific cutting tools, specific process, like a grinding. We call it grinding tools rather than cutting tools, and the material is directly removed by the directly contact between the workpiece and the tools. Right. So there are some key process available: turning, milling, drilling, grinding, sawing, brushing. And what are the characteristics? These are the direct tool and workpiece contact, moderate to high precision, and widely used in the manufacturing because of the cost effective process. Are the some schematics of the turning, milling, drilling, and grinding process? For example, let's say if you can see in the grinding, there's a grinding wheel which is at when it's contact with the workpiece, and there's so due to the high rotation of the grinding wheel, so workpiece is removed by the chipping action, and at the similarly at the same time a constant feed is provided on the grinding wheel, so that to ensure the contact between the workpiece and tools. Advantage and limitations of the traditional metering process. So cost effective for the small and medium production, widely available equipment and skills suitable for metals, plastics, composites, high reliability with CNC computer numerical control systems, and versatile for various part sizes. Limitations are some listed here, like a struggles with hard materials. So some of the super alloy, like a difficult to, also called difficult to cut materials, so it is very difficult to cut using the traditional machining process. Tool wear reduces efficiently, so the tool change is required. Slow for the complex geometry, so jigs and fixes are required to generate, and specific kind of tools are required to generate the complex geometry and generate waste like as in the form of chips and coolant. Since these process are contact type process, so there are a lot of heat generation occurs during the machining process, so coolant is used to protect the workpiece as well as the tool life, increase the tool life. Micro scale features. So now coming to the point of advanced machining process, these are the specialized techniques used for machining hard materials, precise components, and intricate shapes. And these are typically non-traditional, utilizing unconventional methods of material removal such as thermal, mechanical, or chemical energy. And these processes are crucial in industry like aerospace, automotive, medical, and electronics. The some schematics of the advanced machining process: abrasive jet machining, ultrasonic machining process, and electro discharge machining process. So I will discuss about this process later. Some of the advantage of advanced machining process are is hard and brittle metal can also be processed through this machining process, and very high precision can be achieved down to the plus minus 0.005 millimeter. Minimal and no tool wear, so because most of the process are non-contact type. it means there's no contact between tools and workpiece, and machining occurs, ideal for intricate geometry and suitable for thin walled parts. Some limitations like a high equipment and operational cost, slower for some process, material specific like EDM process, electro discharge machining process can be used only for the conductive material, and environmental concerns like chemical, because for example in a chemical process, a machining process, some is used, right, and these are not very environmental friendly, and complex setup and skilled operators are required. Compare like a traditional and advanced machining process on several aspects. You can see the mechanism based is mechanical cutting, while advanced machining processes are thermal, electrical, or chemical energy based. Precision is a moderate to high, and in advanced machining process very high precision can be achieved, and advanced machining process can handle difficult to cut materials or hard materials, super alloy, etc. And cost wise, traditional machining processes are cheaper, yeah, as compared to the advanced machining process. And application, so traditional machining processes are the most widely used and general purpose, and advanced machining process used only where macro or complex shapes are required. Come to the advanced machining process classifications. So I will discuss based on energy source, material removal mechanism, and based on material types, based on process environment, and based on scale of operations. So first I will discuss the advanced machining process classification based on energy source. So mechanical energy based process, in this process are use mechanical energy for material removal, while thermal energy based process use heat energy for material removal, and chemical energy based process use chemical reaction to remove material, while combined energy process it or hybrid, advanced machining process utilize more than one energy source to achieve the material removal, right. So energy based process, in this category there are two most widely used advanced machining processes are available: AGM, abrasive jet machining, and ultrasonic machining. In case of abrasive jet machining, high speed abrasive particles are carried by the gas or air to erode the material, while in ultrasonic machining it uses high frequency ultrasonic vibration with abrasive slurry for precise machining. So you can see on the schematic diagram, like in the left side, there's abrasive jet machining. Here you can see the on in the mixing chamber, gas and abrasive particles are mixed together. So mostly like aluminum oxide and silicon carbide are mostly used as abrasive particles for abrasive jet machining process, and it get mixed with gas or air, right, in mixing chamber, and then it flows through the no passes through the nozzle, which increases the high speed of this mixture, and it directly impacts on the workpiece and in a jet form, so that the exposed area gets erode due to the high speed abrasive jet particles and air mixture. So while in ultrasonic machining process, you can see there's a transducer which generates the high frequency vibration, which is attached to the horn, and this due to the transducer and horn, it vibrates at ultrasonic frequency. This tool and the nozzle, you can see it through the nozzle, abrasive slurry like some solution plus abrasive materials flows through the gap between tools and workpiece, and whatever the material, it's just like those abrasive particles get impacted by the tools at very high frequency, and which remove the materials from the workpiece. Thermal energy based process, in this category there are laser beam machining process that uses a laser beam to melt and vaporize material. Electron beam machining process, it uses focused electron beam to melt or vaporize material, while plasma arc machining uses high temperature plasma to cut and melt materials. And electrical discharge machining process erodes material through the electrical discharge between a tool and the workpiece in a dielectric solution. In the laser beam machining, so laser unit on top is there, and the lens, focusing lens, is used to focus the laser beam directly onto the workpiece, and the area which is exposed by the by the laser light focused laser beam on the workpiece, which is get melt and vaporization occurs, and the material gets removed. While electron beam machine, you can see the electron gun, and it is like a high beam electron beam passes through, right. high speed electrons, and which is material removal takes place at workpiece site. So thermal energy based, also EDM you can see, and plasma arc machining. So now come to the chemical energy based process in this category: electrochemical machining and chemical machining. um, Falls, like in electrochemical machining, bridges electrochemical reaction to dissolve the material. So they are power supply to the tool as well as the workpiece, and generally the workpiece is connected with the anode and the tool is connected to the cathode, and it submerged in electrochemical solution, and material removal takes from the workpiece. So now chemical machining. Here in chemical machining process, it's a removes material using chemical agent, or we call agent, to each or dissolve parts of the workpiece. So here you can see electrochemical machining. There's a tool head or tool electrode, and which is some of the part insulated, covered with the insulator, so that this tool electrode will not get wear during the reaction, and electrolyte solutions flows from the middle side, and the tool and workpiece is connected to the power supply, cathode and anode, you can see here, right? And that some portion of the tool electrode is not insulated, so portion is directly, creates a mirror image on the workpiece. So while in a chemical machining process, you can see the whole workpiece is submerged in a chemical agent, and the area on the workpiece which we don't want to remove, so we put maskant. So that maskant is like a it resists the chemical reaction right under the solution of the agent, and the stirrer is generally used to stir the solution continuously, so that the whatever the material will get removed from the workpiece, it will flow from that zone, so that the effective machining can occur. Some heating or cooling unit is also attached with the chemical machining, depend on the chemical agent. Prove that if at a particular temperature of the chemical agent, the reaction takes place at a faster rate. Now combined energy process, some of the process, you can combine like a laser assisted machining. So it means combines laser energy as well as the mechanical force to enhance the machining. While hybrid manufacturing process are like integrates additive manufacturing, for example, 3D printing with traditional machining techniques to achieve that intricate shapes, very high precision value. Now, classification based on material removal mechanism. Here you can see the under the material removal takes place using by vaporization. Under this category, laser beam machining, electron beam machining, and plasma arc machining is there. Material removal by melting, so LBM and EDM, plasma arc machining. Material removal by erosion. Under this category, abrasive jet machining and ultrasonic machining are there. Material removal by chemical action, electrochemical machining, and chemical machining. Now, classification based on material types. So let's say if your workpiece is metal, then LBM, EDM, and plasma arc machining are suitable. For metals, for non-metals, ultrasonic machining, laser beam machining, abrasive jet machining. While for brittle material, abrasive jet machining is suitable. For composites, water jet cutting, laser assisted machining, ultrasonic machining. While for ceramics and glass, laser beam machining, abrasive jet machining, because glass is brittle in nature, and ultrasonic machining. These are widely used for the ceramic and glass. Classification based on process environment. So dry machining process, as we said, like laser beam machining, abrasive jet machining, and ultrasonic machining. These machining process is like almost dry in nature. And wet machining process, electrochemical machining and water jet cutting. Like these process are machining takes place in wet condition, and hybrid machining process, laser assisted machining, hybrid additive manufacturing, etc. So hybrid machining process. So there are two different degree for hybrid machining process. One called assisted hybrid machining. Second one is combined hybrid machining process. So assisted hybrid machining process are like a heat assisted, vibration assisted, magnetic field assisted, abrasive assisted, external electric field assisted, media assisted like a cryogenic fluid, gas, carbon nanotube, etc. while in the combined hybrid machining process are like for example electric discharge grinding. Here electro discharge machining as well as the grinding process are integrated to each other. Electrochemical discharge, here ECM and EDM are integrated. Laser electrochemical, mechanical electrochemical, electrochemical grinding, EDM, ER fluid assisted polishing, etc. To the classification based on scale of operation. So under this classification, like a macro machining process of larger scale operation with significant material removal. For example, laser beam machining, plasma arc machining, these are very fast and material removal rate is very high. Micro machining process for small scale precision work like a micro ADM, micro laser machining, etc. And nano machining like a for nanomaterial scale feature, nano ADM, nano laser machining, etc. All summary of advanced machining process. So laser beam machining process best for the precise cutting and engraving of hard materials. Electron beam machining suitable for very hard material and fine features. Electrochemical machining ideal for intricate shapes in the conductive materials. Ultrasonic machining best for the brittle materials like ceramics, glass, and composites. Even AGM is also suitable for the brittle materials. So summary table of advanced machining process. So in mechanical energy based AGM, USM, thermal energy based laser beam machining, electron beam machining, plasma arc machining, electron discharge machining, chemical energy based ECM and chemical machining, combined energy like laser assisted machining and hybrid manufacturing. Right, environment dry, LBM, AGM, weight, ECM, water jet cutting. So conclusion. Now come to the conclusion. So advanced machining process are essential in manufacturing high precision components. The choice of process depends on factor such as material types, required precision, scale of operation, and energy source. Advanced machining process enables manufacturer to meet the increasing demand for complex geometry and high performance materials. So these are some reference books you can follow. VK Jain, it's Advanced Machining Process, and Amitabh Ghosh and Malik, Manufacturing Science, East and West Press. So these two books, are the textbook you can follow for the advanced machining process. So let's say if you have any question or query regarding on this topic, you can always share your question or suggestion in the comment section in YouTube. And please subscribe to my YouTube channels. Like we have Nirbhik San Yogi and Nirbhik Gyan, and you can please like, share, and consider donating to supporters. Thank you. And in the coming weeks I will upload the lecture 2 next video. You like this course. Thank you very much.